All right, so this is a video that goes through the classwork for our first section of chapter 3. Use this if you have trouble, and you can obviously fast forward it to the problem that you need help with, or if you want, you could just watch the whole thing. So first question says, 3-1, an exponent is shorthand for repeated multiplication. For example, n to the fourth equals n times n times n times n. In an exponential expression like b to the n, or b to the a, b is called the base, and a is called the exponent. So, the directions for this one say expand each of the expressions below. For example, to expand x to the third, you would write x times x times x. So for a, y to the seventh would be 7y's. For b, we have 5, and then notice only the 2m is to the third power. So I don't have 3 5s. Like I wouldn't write 5 times 5 times 5 because it's not included in the parentheses. So the only thing I have 3 of is the 2m. So I'd have 2m, 2m, 2m. So you have to be careful. If it's not in the parentheses, I don't have 3 of them. Okay. For c, I have x to the third to the second power. So I actually have 2 of these. So I have x to the third times x to the third. Whatever's in the parentheses, that means I have 2 of them. And then, of course, this could expand to 3 x's and 3 more x's. So I have 3 here and 3 here. Then d, I have 4. No power on the 4 except a 1, so I just leave a 4. And then I have x to the fifth, which is 5 x's. And I have y to the second, which is 2 y's. So you should be able to write an exponent problem in expanded form. Now, for 3-2, it says simplify each of the expressions below using what you know about exponents and the number 1. A good hint is you can start by expanding the exponents and then simplify your results. So here I have x times x times x, and I have an x on the bottom. Every time I have an x on the top and an x on the bottom, they cancel out. Which means all I have left is 2 x's on top, which I can write as x squared. For b, I have x to the fifth over x to the second. One way to think about this is to write 5 x's on top, 2 on the bottom. 2 of these cancel with 2 of these, so I have left with x to the third. And if you remember from the note sheet, we do have a formula for this. The shortcut is just take 5 minus 2 is 3. For c, I have 2 x's from x squared, and I have 3 x's from x cubed. I have 5 x's altogether. Remember from our note sheet, we have a rule for this. When you're multiplying powers like this, you just add the exponents. So 2 plus 3 is 5. That would be the shortcut. So let's use the shortcut on d. I have 3 k's here, 5 k's here. My shortcut is to take 3 plus 5 is k to the 8th. On e, you notice this is a division problem, and these are numbers. They're not exponents. So I can just take 16 divided by 8, which is 2. And then I have 3 k's on top, 2 on the bottom. So my shortcut is subtract 3 minus 2 is 1. So I have 2 times k. And it's really 2 times k to the first, but we don't write that 1 usually. But that's 3 minus 2 is 1. For f, if there's no power here, remember there's a 1. So I have 6 m's and 1 m, which is 7 m's. Here I have x to the fourth, x to the fifth, x to the third. This is just a longer version of that rule where we add the exponents. So it'd be 4 plus 5 is 9, plus 3 is 12. So it'd be x to the 12th. For this one, another division problem. 6 divided by 2, of course, is just 3. Now I have an x to the third on top and no x's on the bottom. So there's nothing I can do with that, because all of our rules require that the base of the exponents be the same in order to use them. Now I do have a y over y, which both cancel out, so that's my final answer. Here, I have 5/10. This is the challenge problem. Now, 5/10 is really 1/2. So I can just write 1/2. And then I have 50 x's on top and 15 on the bottom. Remember, our rule is you subtract the exponents when you're dividing. So 50 minus 15 is 35. So my x to the 35th would be my final answer. Notice I put that on top of the fraction because these 15x's cancel out, and I'm left with 35 on top. So that stays here. You could also write this as 1/2 x to the 35th. But that's a challenge one. So that's a little harder. If you flip the sheet over to the second side, we just have more of the same. I have y to the 5th, y to the 2nd, which is really y to the 7th, because you add the exponents. For b, this is division, so I subtract the exponents, so it'd be w to the 3rd. For this one, I have a power and then a power outside parentheses. Our shortcut is to multiply, so that would be x to the 8th. This one, I'm multiplying 2, so that would be adding, so it's x to the 22. Here's a division one. Now it's 13 on top and nothing on the bottom, so I'm going to just leave 13. I can't divide it. I have 4 p's on top, 2 on the bottom, but I use my subtraction rule, so 4 minus 2 is 2, so it's p squared. I have 5 q's on top, 2 q's on the bottom. That's my subtraction rule again. 5 minus 2 is 3. Now f is actually missing something. There's supposed to be a cubed power up here. So this is an interesting one. It means I have 3 of these. So I have x squared over y, x squared over y, x squared over y. So on top, I really have x squared, x squared, x squared, which is x to the 6th. On the bottom, I really have 3 y's. For g, we're starting to get harder now. I'm multiplying. If you just have numbers without exponents, all I do is multiply them. So 5 times 2 is 10. And then I have h and h, so I can combine those because they have the same base. And this h has a 1 on top of it. So it's h to the 1st and h to the 24th. I add them together by our rule, so it's h to the 25th. So numbers in front, I just multiply them like normal. When I have the exponents, then I have to use my rules. Here's h. 10 divided by 2 is 5. And I have 30 m's on top, 8 on the bottom. My rule is to subtract, so 30 minus 8 is 22. Here's I. Now, I have a 3k to the 20th to the 4th power. That means I have 4 of what's in parentheses. So I have 3k to the 20th, 3k to the 20th, 3k to the 20th, 3k to the 20th. So the 3's I can multiply together. They're just numbers. So 3 times 3 is 9, times 3 is 27, times 3 is 81. And then I have 20k's, 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 and 20k's. By a rule, I just add those up. So it's 20 plus 20 is 40, plus 20 is 60, plus 20 is 80. And if you look, this is that rule where I have a power outside parentheses. So my shortcut could have been to go 20 times 4 is 80. And then for the 3, I would just take 3 to the 4th power. That's 81. For j, I have 24 divided by 3. That's just 8. I have an h and an h. Those cancel. And then I have g to the 2nd over g to the 9th. This is a tricky one because I have 2 g's on top and I have 9 on the bottom. Okay, because g squared is on top, that's 2 on the top. G to the 9th's on the bottom, I have 9 g's. So these two cancel out. So I have no G's left on the top of this, but I have 1, 2, 3, 4, 5, 6. I have 7 on the bottom. So under this 8, I have G to the 7th. All my leftover G's after I cancel will be on the bottom. That's kind of tricky. For this one, I have 4 of these. So I have M to the 3rd, M to the 3rd, M to the 3rd, M to the 3rd. And I have N to the 10th, N to the 10th, N to the 10th, N to the 10th. So I have 4 of these. So total I have 3, 6, 9, 12. I have M to the 12th. And I have 10, 20, 30, 40, M to the 40th. So the shortcut here, remember if you have a power outside parentheses, you're supposed to multiply. So I have to multiply 4 times 3, that gets me the 12. And I have to multiply 4 times 10, that gets me the 40. And then for L, you can only do W's together. They have to have the same base to use our rules. So W to the 4th, W to the 3rd is W to the 7th. And the P I have to leave because it doesn't have the same base. So I know these are probably not the easiest thing you've ever done. They can be confusing, so just take your time, use your note sheet. Now you should move on to the Moodle homework. For chapter 3, it's Moodle homework number 1. Thanks.